Welcome to Wildcat Science with Mrs. Haugo. This is Chemistry, Chapter 13, Section 2 on the pH scale, and it's Part 2 of Chapter 13, Notes. So today we're going to jump into the pH scale, obviously, and it is a scale between 0 to 14 that tells you how acidic, basic, or neutral a substance is. So it also tells you how concentrated or dilute that acid or base is. For instance, you could have hydrochloric acid, and if you had a 3 molar concentration of hydrochloric acid and a, let's see, 0.1 molar concentration of hydrochloric acid, they would be different pHs because one of them is stronger, so it has more hydrogen ions in it. So let's take a look at a scale, pH scale. So we know that acidic is low pHs, like concentrated or fairly concentrated hydrochloric acid is 0. Lemons are about 2, vinegar is about 3, apples 4, tomatoes, bananas are actually acidic. Milk is a little bit acidic with that lactic acid. We know 7 is neutral, like water. Your blood is a little bit basic. It's not up here at 8, but it's a little basic. Baking soda is about 9. Soap is about 10. Bleach is, it's pretty caustic, it's pretty corrosive. That's 12. And drain cleaner is 14. It's very basic. So if you look in your book on table 13.3, page 416, there's the pH of some common acids and bases. And we're going to be working with scientific notation. So, like 5.0 times 10 to the negative second. Page 417 in your book reviews that. Just a quick review of that concept. Okay, so pH is not just how acidic or basic something is. It is technically the negative log of the hydronium concentration. So we're going to break that down just a little bit more. pH is based on a logarithmic scale. So a logarithmic scale is one where instead of between 1 and 2, it's 1 change. Between 1 and 2, it's 10 times as much. So if you have, please write this down, log scales are based on orders of magnitude. So a pH of 1 is 10 times more acidic than a pH of 2. And then a pH of 1 is 10 times 10 times more acidic than a pH of 3. So you can see as you're going away from neutral, you get more acidic very quickly. So let's talk about how logs work. And then we'll talk about these brackets we know means concentration, which is molarity, and we know hydronium is another way of saying like a hydrogen ion, like it's acidic if it gives off a hydrogen ion, and we know those hydrogen ions kind of glom onto the nearest water molecule and will make H3O plus hydronium ions. All right, so jumping back into logarithmic scales. So let's have this equation where we have 10 to the exponent b equals some number n. The log is kind of the opposite of exponents. So like multiplication and division are opposites. Addition and subtraction are opposites. So exponents and logs are opposites. So if you take the log of your answer, you're going to get your exponent. So 10 to the b equals n, and then log of n equals b. So let's write down some examples. The log of 1 equals 0. So log of 1 equals 0 because 10 to the 0 equals 1. The log of 10 equals 1 because 10 to the first equals 10. So the log of 10 would equal 1, your exponent. I want you to write down some more just so we really get this in our brains. The log of 100 is 2. So the log of 100 is 2 because 10 squared equals 100. The log of 1,000 is 3 because the log of 1,000 is 3 because 10 to the third equals 1,000. All right, I'm just going to make you write down 2 more. The log of 10,000 equals 4 because 10 to the fourth equals 10,000. Last one. The log of 10,000 equals 5 because 10 to the fifth equals 100,000. Okay, so I feel like you're getting the pattern. Now I'm going to flip it up on you a little bit. Negatives. So negative, if the answer to your log is negative, your number isn't negative, it means we're getting into decimals. We're getting less than 1. So the log of 0.1 equals negative 1 because we know 10 to the negative first equals 0.1. And then the same thing with the log of 0.01 equals negative 2 because 10 to the negative 2 equals 0.01. And the log of 0.001 equals negative 3 because 10 to the negative third equals 0.001. All right, I'm going to make you write a couple more. The log of 1, 2, 3, so tens, hundreds, thousandths, 10 thousandths equals negative 4 because 10 to the negative fourth equals 1 10,000th. And then the log of tens, hundreds, thousands, 10 thousandths, 100 thousandths equals negative 5 because 10 to the negative fifth equals 100,000th. All right, now I'm going to do something that isn't a factor of 10. The log of 2 would be 0.30 because 10 to the 0.30 equals 2. So if it's a factor of 10, you could probably do that in your head. And if it is not, it would be very hard to do in your head. So I would recommend a scientific calculator. And it should have a log button. And the log button should, if you don't see it right away, it's often on top, like a second function of the 10 caret, the exponent button. All right, so you want to get comfortable doing that. So find a calculator and make sure you can get that answer. Okay, so looking at a table, you don't have to copy this down, but let's take a peek at it. So if you have a pH of 0, then you have 1 molar hydrogen ions. If you have a pH of 1, so that's 10 to the negative 1, you'd have 0.1 molar concentration of hydrogen ions. Jumping down to pH of 5, you have 10 to the negative fifth, which would be 0.00001 molar concentration of hydrogen ions. So coming up here, or down here, but higher in pH, to a pH of 9, it would be 10 to the negative ninth equals 1, 2, 3, 4, 5, 6, 7, 8 zeros and a 1 molar concentration of hydrogen ions. If you see, here is the natural concentration of hydrogen ions in water. And then if you have more concentration than hydrogen ions, it's considered acidic. And if it's less concentrated than neutral water, it's considered basic. And we can see as your hydrogen ions become more common, your hydroxide ions become more dilute. And then the opposite is true. When you have more hydroxide ions, you have more dilute or fewer hydronium ions. Okay, now we're going to solve some problems. Yay! Please write this down. A solution of acetic acid, HC2H3O2, has a hydrogen concentration of 5.0 times 10 to the negative fifth molar, what is the pH of the solution? All right, so write that down and find a calculator. Okay, wonderful. You should have this written down and you should have a calculator. So the first thing we're going to do is write down our equation. And as you know, the equation is pH equals the negative log of the hydronium concentration. So let's see, what are we trying to figure out? We're trying to figure out the pH, and we know the hydronium concentration because it told us a concentration. 5.0 times 10 to the negative fifth molar. So I will plug in my numbers below that. Negative log, concentration is in brackets, 5.0 times 10 to the negative fifth molar. And then on my third line, I'm going to write the answer. So if you pick up your calculator and you put opposite log, and then in parentheses, 5.0 times 10 to the negative fifth, parentheses, you should get something, not something like, but exactly 4.301, and it goes on from there. So let's see how many sig figs we get. Oh, we have 2. So our pH with 2 sig figs is 4.3. Now, let's make sure that we answer the question and it makes sense. So, pH. What is the pH? Yes, we answered the question. Now, 5.0 times 10 to the negative fifth. We know 10 to the negative fifth would be like 0.00005. And so that has between 4 and 5 zeros. Let's go back and I'll show you what I mean. That has between here 4 and 5 zeros, so it should have a pH between 4 and 5. And does it? Yes, it does. Good job. We answered the question and we have a reasonable answer. Now, how could we go backwards? Given a hydronium, how could we find the hydronium concentration given the pH? Again, we are going to write the equation and then sub in your numbers. So please write the, put myself up a little higher. Please write the problem. Example 2, find the hydronium concentration of a solution of nitric acid with a pH of 3.5. So, write the equation, pH equals negative log of the hydronium concentration. Well, we know it has a pH of 3.5. 3.5 equals the negative log of the hydronium concentration. So then, we're going to have to undo all the parts on the right. So we know the opposite of timesing by negative 1. We are going to, if we times negative 1, we get 1, so we're going to times negative 1 on each side. So then we get negative 3.5 equals the log of the hydronium concentration. But how do we undo logs? If you remember, I told you that logs are the opposite of exponents. So the opposite of a log is an exponent to the base 10. Okay, so we're going to do base 10 to the exponent log hydronium concentration, and then we're going to do base 10 to the exponent of negative 3.5. So I want you to put that in your calculator and solve that, and we're going to finish up and talk about it in a quick little video after this one. I'll see you then. Bye.